Hello friends, today I will discuss the numerical problems on supernode analysis. In the previous classes, we have seen what is mesh analysis and what is super mesh analysis, why we call super mesh analysis, and how to solve the super mesh circuits. Today, we are going to study the problems on the supernode analysis. So here, before we discuss or before we solve the numerical problems on the supernode analysis, so let us know first what is the definition of supernode or what is the definition of supernode circuit. And then we use those definitions to the given problem. So we say there are two cases to say the circuit is supernode circuit. Case 1, when the voltage source is connected between the reference node and the non-reference node. And case 2 is when the voltage source is connected between the two non-reference nodes. What is meant by a reference node? What is meant by non-reference node? So that we discuss now with respect to the given problem. So look at this. So the given problem is like this. So he wants what is V1 and what is V2 using the supernode method. So if we look at this diagram, here we have a 2 amperes current source in parallel with a 2 ohms resistor. Similarly, there is a 7 amperes current source in parallel with 4 ohms resistor. And here between V1 and V2 there is a voltage source called 2 volts, and between this 2 volts supply there is a 10 ohm parallel resistor like this. Here there are totally 3 nodes. This is one node, this is another node. What is meant by node? Node is nothing but joining of 2 or 3 points, or normally 3 elements at one point is called the major node, or simply we call that as node. So if you look at this, this is one element, this is another element, this is another element, this is another element. 4 elements are meeting at one point. We call this as V1 or first node. And here this is one element, this is one element, this is another element, this is another element. There are 4 node elements which are connected together at one point, and this we call as second node, and this is nothing but its voltage we designate with as V2. This is V1 and this is V2. And these nodes, this V1 and V2, are called the non-reference nodes. Whereas here we have the return path. This is one node, this is another node, this is another node, this is another node. These are the minor nodes. So we can connect all this together like this. And this node means all these elements put together is called the reference node. So we say the circuit is supernode circuit when the voltage source exists between the non-reference nodes or between reference node and the non-reference node. This is the reference node and this is the non-reference node. There is no voltage source between this point and this reference node. Similarly, this is one node, this is the reference node. There is no voltage source between this and this. So second condition is not valid. Then what is the first condition? Is there any voltage source between the non-reference nodes? Yes, this is V1 is non-reference node, this V2 is also non-reference node. Between these 2 points there is a voltage source 2 volts. So we say this circuit is a supernode circuit. To solve this supernode circuit, you cannot use the ordinary node method. So to solve this, we have to adopt a different method. So let us first write the steps What are the steps? There are only 3 steps involved in solving this problem. The first step is identify the number of nodes. So here if you look at this return path is called reference node, and this is one node, this is another node. So this is one, this is another, this is another. Totally 3 nodes. So we say number of nodes identified is 3. Next, assign the nodes and assign the current directions from the nodes. Third step is write the voltage equations for node 1, that is V1, and also V2. Then node equations So then we have to write the node equations at the super node, that is called super node equation. After this, fifth step is we have to solve equations first one and second one to get the V1 and V2 values. Remember here, so though this is a nodal method, we are using a voltage equation and a current equation. So without voltage equation, we cannot use the just KCL and solve this problem. So to solve this problem, we are going to use both KVL and KCL. So what is the first step? Identifying the number of nodes. That is already over. That is 3 nodes. This is 1, 2, this is 3. So this is called reference node. These are the non-reference nodes. And non-reference voltages are called V1 and V2. So now assign the current direction from each node. We assume that V1 is at a higher potential compared to the other nodes. So the current flows from here in this branch like this. Similarly in this branch from top to bottom. Similarly the current flows from here to here. So next, similarly there is another node here. Here also we assume this V2 is at a higher potential compared to the other nodes. So the current flows in this branch from top to bottom. So similarly in the 4 ohms current flows from top to bottom. Similarly there is another current flowing from V2 towards this branch. So next, once that is done, now we can write what is the voltage equation between the non-reference nodes. If you look at this, V2 is at higher potential than V1. So V2 minus V1 is nothing but 2 volts. So this is called voltage equation. And we say this is equation 1. And here we do not know what is the current flowing in this. But it is existing between the two non-reference nodes. So, and a branch across this source is available, that is 10 ohms. When this situation occurs, then we have to assume this node, this voltage source as a super node. So means this element and these nodes put together we call as super node. Means we assume that node means single node having the voltage equal to V1 is equal to V2 like this. So in the bracket lines we have put all these 3. This is one, this another, this is one, this another. So totally 4 parameters we put together and we call that as super node. So that's similar, we can write like this. This is V1 with the 2 currents going. So this side one current flowing, this another current flowing. Similarly from V2, one current flowing like this, the another current flowing like this. Means for one node we can write one nodal equation. So how to write that? So from V1 there is a current flowing called 2 amperes, but it is flowing in the opposite direction. So we say this current as minus 2 amperes like this. Next, V1 by 2, because current is leaving, so we put plus. So plus V1 by 2. Next, go to this node, that is V2, which is also comes under the super node. So two currents are leaving, one current flowing like this, the other another current flowing like this. So current flowing in 4 ohm resistor, we write V2 by 4, because for same node we are writing, so we say plus V2 by 4. There is another current flowing called 7 amperes flowing in the same assumed current direction, say, and it is leaving, so we say that is plus 7 like this. This is called the super node equation. So this is nothing but current equation. And then you simplify this. Once we simplify this, we get minus 8 plus 2v1 plus v2 plus 28 is equal to 0. And then if we further simplify this, we get 2v1 plus v2 is equal to minus 20. And we say this is equation 2. So equation 1 is voltage equation. Equation 2 is the current equation. Equation 2 is current equation. So subtract the equation 1 from equation 2. So look at this. When you subtract this, first write the equation 2. That is 2v1 plus v2 is equal to minus 20. And equation 1 is given as v2 minus v1 is equal to 2. So you subtract this second equation, that is equation 1. So once we subtract, we get like this: 2v1 plus v2 minus v2 minus of minus v1 means plus v1. So this v2 and this v2 going to get cancelled, and this 2v1 this v1 going to get added. So we get 3v1. So then here right side minus 20 minus 2. So we get minus 22. Once we solve this, we get v1 value is minus 22 by 3 volts. So once we know this, substitute that V1 in this equation, that is equation 2. Then we get V2 is equal to minus 20 minus 2V1. So minus 2 into V1 means this, minus 22 by 3. So once we simplify this, we get V2 is equal to minus 16 by 3 volts. So to solve a super node based problem, first of all we should know whether that problem belongs to the super node method or not, and after that we have to know so where to write the voltage equation, then where to identify the super node, and from that super node we have to write the current equation, then we have to relate the voltage equation and current equation, and then solve for the unknown values, like in this case V1 and V2, which are obtained as minus 22 by 3 volts is V1 and V2 is minus 16 by 3 volts.